A few days ago, there was a debate between Sean Carroll and William Lane Craig that I think is the greatest Craig debate I've ever seen. What I liked most about it was that Sean Carroll, who is a physicist, was actually knowledgeable enough to tell Craig that pretty much everything he says about physics is wrong. So this video is basically just going to show the highlights of that debate. These were all of my favorite parts. The whole thing is over 2 hours long, so this is a little bit of a TLDW. Craig, of course, starts with the Kalam argument, the first premise of which is everything which begins to exist has a cause. And Sean Carroll pointed out that
the problem with this premise is that it is false. There's almost no explanation or justification given for this premise in Dr. Craig's presentation, but there's a bigger problem with it, which is that it is not even false. The real problem is that these are not the right vocabulary words to be using when we discuss fundamental physics and cosmology. This kind of Aristotelian analysis of causation was cutting-edge stuff 2,500 years ago. Today we know better. Our metaphysics must follow our physics. That's what the word metaphysics means. And modern physics, you open a quantum field theory textbook or a general relativity textbook, you will not find the words transcendent cause anywhere.
Of course, Craig's response was predictably incredulous.
Honestly, I'm quite astonished that he would think the universe can literally pop into being out of nothing.
And Carroll responds appropriately.
He said he was astonished that I refused to accept the fact that things need causes to happen, to which I can only quote David Lewis, "I do not know how to refute an incredulous stare."
The second premise of the Kalam argument is that the universe began to exist. And Craig often cites the Bordet-Guth-Vilenkin theorem as saying that whatever model of the universe you use, they all must have a beginning. I've often said that this is a misinterpretation of that theorem, but finally a physicist sets Craig straight on that issue.
So I'd like to talk about the Bordet-Guth-Vilenkin theorem, since Dr. Craig emphasizes it, and the rough translation is that in some universes, not all, the space-time description that we have as a classical space-time breaks down at some point in the past. Where Dr. Craig says that the Bordet-Guth-Vilenkin theorem implies the universe had a beginning, that is false. That is not what it says. What it says is that our ability to describe the universe classically, that is to say not including the effects of quantum mechanics, gives out.
Craig, of course, doesn't accept this, but what Carroll does later is fucking priceless.
In case you don't trust me, I happen to have Alan Guth right here, one of the authors of the Bordet-Guth-Vilenkin theorem. Alan, what do you say? He says, I don't know whether the universe had a beginning. I suspect the universe didn't have a beginning. It's very likely eternal, but nobody knows. Now, how in the world can the author of the Bordet-Guth-Vilenkin theorem say the universe is probably eternal for the reasons I've already told you? The theorem is only about classical descriptions of the universe, not about the universe itself.
Now this shows what an incredibly nice guy Sean Carroll is, because if I were in his shoes at that moment, I would have been like, tell me how my ass tastes, Craig. And Craig's response is equally priceless.
That could be his predisposition or his hope or hunch or something of that sort.
As is Sean Carroll's response to that.
Alan Guth does not believe the universe is eternal because it's a hunch or a personal preference. It's because he's a scientist and he's trying to develop models that fit the data. We have puzzles in cosmology. Given his knowledge of the models, he believes the best way forward, the most promising way forward, are the models in which the universe is eternal.
Elbow from the fucking sky. When Craig talks about the fine-tuning issue, he says that if you change even the slightest minute details about the constants of the universe, life cannot exist. Therefore, there must have been a designer which fine-tuned the universe for life. Sean Carroll rightly points out that if you change these details, it is true that life as we know it could not exist. But we have absolutely no grounds in which to assert that there couldn't be some variety of life or some kind of intelligent observer that can exist in universes that has properties different from our own.
It is certainly true that if you change the parameters of nature, our local conditions that we observe around us would change by a lot. I grant that quickly. I do not grant that therefore life could not exist. I will start granting that once someone tells me the conditions under which life can exist. What is the definition of life, for example? If it's just information processing, thinking, or something like that, there's a huge panoply of possibilities. They sound very science fiction-y, but then again, you're the one who's changing the parameters of the universe. The results are going to sound like they come from a science fiction novel. Sadly, we just don't know whether life could exist if the conditions of our universe were very different, because we only see the universe that we see.
A common reply to the fine-tuning argument is the multiverse hypothesis. Craig likes to bring up the Boltzmann brain problem with the multiverse hypothesis. This basically is the idea that if there are so many other universes, that there are enough of them to outweigh the rarity of the fine-tuning of this universe, then there would have to be so many universes that the number of universes in which random quantum fluctuations produced whole brains spontaneously would be vastly more common than universes like this one. So it should be vastly more likely that we experience ourselves existing as one of these spontaneously generated brains, rather than finding ourselves existing in this universe. Sean Carroll points out that this is not necessarily the case.
This is a significant misunderstanding of how the multiverse works. The multiverse doesn't say that everything that can possibly happen happens with equal probability. It says that there's a definite history of the multiverse and you can make predictions. Different multiverse models will have different ratios of ordinary observers to random observers. That's a good thing. That helps us distinguish between viable models of the multiverse and non-viable models. And there are plenty of viable models where the Boltzmann brain or random fluctuations do not dominate.
This was probably the biggest ass-kicking that I've ever seen William Lane Craig get, so I'll put a link to the full debate in the description. Check it out. I think this is the definitive William Lane Craig smackdown. I think after this, if he keeps trying to use cosmology or physics to justify theism, it will be nothing but embarrassing.